So let's start the next section, and here's Luís Fontes, who's going to be talking about GitHub Actions. Luís, it's yours.
Thank you. Hello. So my name is Luís Fontes. I work as a product security engineer at a bank. And I've been working with GitHub Actions for a while and trying to secure some GitHub Actions for some companies. And I've seen some common patterns, let's say, and bad designs that I want to bring some awareness of. And that's basically what I'm going to do in this meeting, in this presentation. So first of all, I'm not going to be talking about things like CI/CD top 10 or something like that. It's just common designs that I've seen everybody implementing that had some security implementations. So I hope it can be helpful for you guys. So first of all, what is GitHub Actions? So it's basically a CI/CD tool from GitHub where you can basically build, deploy, test your code. And it works basically like Jenkins or Bitbucket and so on. And it has some nice features. You basically create definitions on the code and it will run the CI for you. But this brings also some challenges, mainly securing these pipelines. So most of the things that I see are basically on the CD part, so on the deployment. And this is because you either need to deploy, for example, to AWS or to Google Cloud or something like that. And you need to have some kind of permissions to push your code, either credentials, runners with whitelists and so on. And there are a lot of things that can go wrong here. So first of all, you can basically somehow leverage the secrets on GitHub. You can compromise the machines that do the deployment for you, and from there you can do a lot of privilege escalation or lateral movements. And I've seen, for example, a case where a user had a regular write access to a GitHub repo, and it got from there to an AWS admin. So that's how bad that can go. And let's hope that we don't see a lot of those, but it can go that way. So first of all, the most important part is to understand how GitHub Actions work, right? So as long as you have right permissions to a repository, you can basically run the pipelines, the actions itself, or the workflows, and you can basically change them as you want and do whatever you want with them. So let me show you how you can break with all of those things. So first of all, GitHub has a thing called secrets, and it's basically supposed for you to store your passwords, your credentials there, so that you don't hard code them in the code. But the name can be misleading, right? So when you actually have a secret, you can extract that secret, you can dump it, and although you cannot do it from the UI, it gives you a false sense of security, because if you can actually control the action or the workflow, and for that you only need right permissions, you can basically extract any secret configured in a repo or in an organization. So that's mainly the first thing that you see failing. So a lot of companies create secrets and store them, most of them even in organization level, and you can just create a random repository with no permissions. You create an action and you have access to all the organization secrets, and it's just dumping all of them quite easily. So in this image, you have a definition of a workflow at the left, and at the right, you have the run of that workflow. And basically, as you can see, if you try to do an echo of a secret on GitHub, GitHub will automatically hide the secret from you in the output. The issue with this is that GitHub is basically doing a find, search and replace. So if you have a secret with a value test, and if you have a test in the output, GitHub will filter that word test. So if you start doing things like base64 encoding it, or print a character and a space, a character, a space, or just a character per line, you can easily dump a secret. Obviously, you can do things much more complex, like doing requests to external web servers to send the secrets, but basically, as long as you don't print the secret as is, you can basically print it in the output. And this is where all starts, right? So most of things are secured with secrets still, and you can start dumping them quite easily. Again, You just need write access to the repo. Branch protections don't work because as soon as you create a new repo, you can control the workflow, and you can change the entire workflow and put that wherever you want, and your version of the workflow will run even before it's merged to the default branch, to master or dev or wherever is the default branch. So this is one of the most common things, usually one of the most dangerous as well. So still on secrets, when you run a workflow, GitHub generates automatically for you a secret called GitHub token, and this is ephemeral, so it only lasts as long as your action is running. So the thing about this token is that it has basically, by default, write permissions to the repository that you're working on. So you can basically call the API and do operations on the repo level. So for example here, you have, I thought I had an example. But here you can see the default permissions on the workflow, which has read and write permissions, and you can also have the token the token can also be used to approve PR. So there was a security issue reported a while ago where branch protections that had like minimal one approval for merging PRs could basically bypass that by using the GitHub token to approve the PR and merge it. So obviously you can also leverage this token to do malicious things. It shouldn't be that necessary because if you have write permissions to the repo, by default you don't need to use this token. But this gets more interesting when you start using third-party actions, right? So basically an action can be compared like a library in a piece of code. So it's something that you import to do a generic task or a common task. And you can send that GitHub token to the action to do something for you. For example, in this case, we have a creation of a release in GitHub, and you need to send the GitHub token for it to be able to call the API and do the release process. So by default, when you're actually sending this GitHub token to the action, it will inherit all the write permissions that the token has, right? What can go wrong with this is that you don't know what the action is doing. And for example, in this case, you just have the action tagged to version 3, but you can have multiple version 3s, and the latest one can do something that you're not expecting, for example, and leveraging that token for something that it's not supposed to. So it's really hard to control what the action is actually doing, unless you for example pin it to the commit hash and you review that commit to make sure it's safe. So one thing that you should do with this, so whenever you're sending GitHub tokens to third-party actions, you should always make sure that you specify which permissions the token can have. So there's an option on the workflows where you can say this token will only have read permissions to the repo, for example, and you should trim it down to the basically essentials of what the action needs to use the token for. I've also seen some common issues with the GitHub tokens on malicious third-party actions that leverage the token permissions for things that shouldn't be using it. Okay. In this case, we have an example of running a workflow in your own branch, as I said before. So let's say that you have branching policies, branching rules in place, so that you need, let's say, two reviews to merge to master, for example, and you have an entire workflow to push to production, let's say. And you're quite confident that you have a secret there and can't be dumped because you need two approvals to actually merge the code. So that's not what happens, and this is a big misconception. And there are a lot of security issues also around this, because people don't understand that you can create your own branch and just change the workflow and run your version of the workflow even before being approved. So approvals mean nothing. Code owners don't do anything either. So the workflows can always be controlled by anybody with write access to the repo. So here, the same thing. So you have on the left side an example of a change on my own branch, and on the right you can see that the changes that I did run and took effect. So another cool thing is the workflow dispatch tag. So this is something that you specify on the workflows and basically mean that as soon as you add this, you can run the workflow from the UI. So by default, you run workflows on trigger events like when I do a push, when I do a PR. On this case, you can basically manually invoke a workflow and you can even specify user input if you want or need. And usually there's also common injection here when you ask for inputs because they almost always end up in a shell script. But yeah, so a thing about the workflow dispatch is that you can run the workflow dispatch also from any branch that you want. And a lot of times when developers add this workflow dispatch, they don't have that into account. So you can basically go to the UI, run a workflow on your own branch, and for example, deploy a malicious version of your code. Another issue with that is that, I don't know if you can see it here. No. But basically, let me... yeah, so I think I have a line there. So when you create this, you need to actually push this to master to be... you need to push a version of the code with a workflow dispatch to master to actually show up in the UI. So if you don't have this in the master branch the first time, you don't have this option, but as soon as you put this option on the main branch, it will show up in UI and you can basically call the workflow from any branch. So all of these issues can happen because when you work on an organization, you're expecting to have some segregation, right, and some restrictions about permission. So if I have a team working with repo A, B, and C, I don't want them to have access to D and E, for example, right? Because they shouldn't have access to things they don't need to do their work. And when you start thinking about all of these things and the insider thread risk that you have here, most of the times companies, a member inside the company can leverage all of these permissions and basically take down a lot of things that they should not have access. Okay, another cool thing that GitHub implemented, and it's somehow trying to help with the secrets, it's the concept of environments. So environments allow you to define like a set of rules, like you can say that a workflow will only run on this specific branch, or for this workflow to run, I need 2 approvals from X, Y, and Z. So that's interesting, but the thing is that you define which environments are associated to the workflows in the workflow file. So if you own the workflow file, right, you can just remove the environment tag and it's game over. So although environments work, you have to be careful with that because a cool thing also about environments is that you can store secrets in the environment. So instead of having secrets associated with the repo, you can associate them with the environment. And they are only injected in your workflow if all the conditions in the environment pass. So let's say that I have a password to deploy to AWS. Obviously, you shouldn't do this way, but let's say you have on an environment. Unless the environment passes like with 2 approvals and it's running from the main branch, that secret will never be injected into the workflow. So for environments to actually work, you need to have secrets, and those secrets need to do something interesting. Otherwise, you can just remove the tag and you bypass all the features of environments. And it's also a common misconception that people add environments with approvals and you just go to the workflow and just remove it. So another nice thing, and because I think I made my point that secrets are hard to manage on GitHub, another thing is to use self-hosted runners. So by default, when you run a workflow, it runs on a container controlled by GitHub, right? So they have this container is called runner, by the way. So you have a concept there that is self-hosted runners. And basically, you can configure your own machine anywhere to run the workflow for you. So for example, if you configure an EC2 or some container on AWS, it's much cheaper than running a a runner on GitHub. So that's mainly the main motivation to use self-hosted runners most of the times. But they have some cool advantages as well. So when you're using a self-hosted runner, you don't need to have secrets on GitHub, because if you have a self-hosted runner, for example, on AWS, you can leverage that and just use the permissions that your runner has inside AWS to do wherever you need to. But this also comes with some challenges. So if you do this, you basically have a backdoor to your systems, right? So if I control the workflow and I can run whatever I want in my workflow, I can basically control the self-hosted runner, which can be a huge risk as well. So there are some pros and cons on using self-hosted runners. You need to make sure, if you use one, you need to make sure that you lock them down pretty well, otherwise you'll have some issues. The cool thing is that when you configure a self-hosted runner, it's the self-hosted runner that connects to GitHub and not the other way around. So that's why you don't need any kind of permissions on GitHub. So even admin users don't control the runner by itself, just from the workflows. So having seen all of this, let's see some ways of actually exploiting GitHub Actions and try to be silent so that you don't get caught and nobody sees what you're doing. So obviously there are tons of ways, and the imagination is the limit, right? But there are some interesting things of what you can do to hide your tracks. So in this case, you can see that I just ran a workflow, and for each step in the workflow, GitHub prints what it's going to do. So in this case, I'm pushing a version of an extension that I have, and you can see basically all the code that it's being run on the workflow. So if you change a workflow and add some malicious code there, it will be printed as the output of the step. So what you can do is that you can find, for example, a workflow that it's calling an external script, and you can change the external script. So you create your own branch, you change that script, and you don't see anything in the logs, because if you're just calling a script from the workflow, what you see in the output is that you call the script. You don't see the content of the script, right? So, and you can start from there, and you can create even more complex things. So for example, in this case, this is a little bit complex for trying to be quiet, but the idea is that you have an external server, and you find a workflow that is calling a bash script or something, and you create your own branch, you change the bash script, you add your logic, for example, to retrieve some malicious code from a server, and after retrieving it, you shut down the server so nobody else can do the same request and get the same code. And you basically run your script, and you shut down the server, and you delete the branch. So from there, it will be really hard to try to understand what you did, because you basically deleted the branch with the changes on your script. So it's not easy to find these kind of actions, and that's why you should always try to limit the GitHub actions as best as possible. And I have some tips for that as well. So, first of all, as I said before, it's securing the GitHub token, so you can basically specify the permissions that GitHub token will have. So when you're sending it to a third-party action, they cannot abuse that much of your token. So another cool one is to specify which actions you allow to be run on your organization or on your own repos. If you're doing this on your own repos, it's not that important, because probably nobody else will control them, right? But when we're talking about organizations, anybody can just use any third-party action, and there can be a lot of issues with that. So you should try to restrict which actions can be run, and you can even pin them to specific commit hashes, which is the best scenario here, because you can review those specific commits and make sure there are no issues. If you pin them for a version, I don't know if you guys try this, but you can just delete a version that you created on GitHub and create the exactly same version with different code. So it's not that worth it. Okay. Another one, and I covered that one as well, it's disabling the PR approvals permissions from the GitHub. A lot of companies have like one approval, two. If it's just one, it's critical, because you can basically bypass and merge to master wherever you want. And that's basically it, because I don't have more time as well. So questions?
Yes, this one. Thank you, Luís. Any question for Luís we have before our break? Anyone? Okay. Thank you, Luís, for your
That was easy.
presentation.
Thank you.
Thank you all.